All right, so this next one says graph the system of inequalities below. So this is still linear programming, guys. All right, name the coordinates of the vertices of the feasible region and find the maximum and minimum values for the function 2x plus 3y. Okay, so we have our constraints. Don't really know if it's in first quadrant, second quadrant, or what, so I'm going to go ahead and draw my whole Cartesian plane. X-intercepts, y-intercepts for each one. I'm going to number each line. So if I plug in 0 for y, so cover up the y, you get negative x equals 2. So that means x is negative 2. Plug in 0 for x, you get 2y equals 2. So y equals 1. Okay, so I have negative 2, 0, and I have 0, 1. That's line number 1. So remember to go ahead and mark it just in case you need to use that line later. Okay, line 2. Plug in 0 for y, you get x is 4, so 4, 0. Plug in 0 for x, you get negative 2 for y. So I have 4, 0, negative 2. Draw your line. Now, if you're really careful, you will see that those lines are actually parallel. If you're sloppy, though, you might want to check, because you might say, they look like they're parallel, but I'm not sure. So how can you check to see if they're parallel? Same slope. You could put them in y equals mx plus b to find their slope, or you can count rise over run. So see, on this one, I go up 1, right 2. So that means the rise over run was 1/2. On the other one, I go up 2, right 4. Same number? Yeah, 1/2 is the same as 2/4. So they are parallel. I know that. All right, third line. Both the y-intercept and x-intercept are going to be negative 2. Which are points we already have? Okay. What? Yeah, it's kind of nice. Now I'm realizing I didn't do my shading, so let's go back and think about the shading. So my first line, if you plug in 0, 0, you get 0 is less than or equal to 2. That's true. So for my blue line, I'm going to shade towards 0, 0. So I'd shade downwards. For the red line, I plug in 0, 0, I get 0 is less than or equal to 4. That's also true. So now I shade up. So now I'm just this very thin parallel strip. So like this. That's where I'm at right now. Now with the green line, if you plug in 0, 0, you get 0 is greater than or equal to negative 2. That is also true. So now shade towards the point 0, 0. So you're going to shade upwards. So our final shaded region goes off forever to the right, the upper right. It's what we call unbounded. It's not a shade frame. All right, it's unbounded. All right, so when this happens, so if something is unbounded, this is important, guys. So if unbounded you must try all corner points and a point on the inside. Do you know what I mean by inside? Like in the shaded area. So a point on the inside in your function. Okay. So for my function, kind of a weird way to write functions, right? It's just saying that, like a profit equation, you have x and y you can plug in for, so f of x comma y. Okay. I'm going to have these 2 points So I'm going to call it A and B. And then I'm going to pick some point on the inside. What point would you guys like to pick on the inside? 0, 0. You guys are smart. So C. So A was 0, -2, B was -2, 0, and C was 0, 0. So any point. So any point in the shaded area. And we try them in this f of x, comma y. So really the technical way you should write it is f of 0, comma -2 equals something. You could just write f though, I wouldn't be mad. So you get -2 goes in for y, so you get 2 times 0 plus 3 times -2, so -6. What's f of -2, comma 0? -4. And what's f of 0, 0? 0. Okay. If one of those, if the number that is your maximum number, so our maximum number is in that point that we selected that was in the shaded area. So since this, so since our max was in shaded area, we say there is no maximum. Okay, think about that. Why would we say that? Yeah, we didn't have to pick 0, 0. We could have picked any point. So let's say I pick a number way up here. So I go out to 100, comma 100. Okay, it's not inside. So pick a number that's inside and that has really big x and really big y. I don't know what's in there. So let's say we pick a number that has a really big x value, a really huge y value, and you're plugging it into our f of x, or f of x, comma y. Do you see that that would be a really, really huge number? Yeah, and there's no limit to how big your x's and y's can go because it was unbounded on that side. Yes?
You say like negative infinity, or not negative infinity, but like infinity and infinity.
Yeah, it's kind of like, yeah, you could go up to infinity, right?
Could like,
You never reach infinity though. But yeah, that's basically what you're saying. There's an infinite maximum. You never reach that maximum. All right, now what would your minimum be though?
karma right there.
Yeah. Guys. So minimum of -6 at 0, comma -2. Makes sense? So no maximum, minimum of -6 at 0, -2.
You have to put that.
How would you?
You have to put that.
Yes. Yeah, you have to put the minimum. I asked for both. All right, now let's go to 3.5. I'm not going to do all of it today, but I wanted to show you a couple examples so you can start on your homework. Yeah, cool graph. All right, so steps to solving a system of equations with 3 variables and 3 equations. So before, we've done things like 2x plus y equals 6, and 3x minus y equals 5, and we've solved things like that, right? Yes? Substitution, elimination. So when we had 2 variables, we needed at least 2 equations to solve. If I have 3 variables, I need 3 equations. If I have 4, I need 4 equations. So now we're going to learn how to solve with 3 equations. Now the reason that I am going ahead and doing a couple of these examples is because today in class for the rest of our double and for tonight, I want you guys to work on the 4 questions in 3.5 because they're kind of hard. It's like one of the hardest assignments every year that I give. Because people get careless, they make one simple mistake, like forget a negative. They mess up their x value, and then they mess up their y value and their z value, because they make a simple mistake. So you need to be very, very careful on these. Go slowly. Don't do it while talking on the phone to someone. Don't listen to music. Concentrate on it, okay? So, all right, so number 1. Now my steps, it says decide which variable is easiest to eliminate. So when I look at number 1, you think z looks easy?
Or y. Z or y.
I think y or x looks easiest. Do you guys see? So see how I could just combine the first 2 equations? So add straight down with the first 2 equations, and you would get rid of x. Okay, or you could add the first two equations. Did I say first two on the last one? First and third. Yeah, or you can combine the first two equations and get rid of y. Okay, so just decide which one you want to get rid of.
Can you combine the first two and then combine the third?
What do you mean? Combine these two and then use the third?
Yeah.
Yeah, so we're not going to do like all three at once. We're going to do two at a time. All right, so let's say we're going to do the first and third equations. So I'm going to have x minus 2y minus z equals 6, negative x minus y plus 2z equals 1. Add straight down. X's go away, which is what we wanted. I have negative 3y plus z equals 7. That's a new equation with just y and z in it. Now that I've used the first and the third equation, I have to use the second now. So now you have to use equation number 2. So you can number them if you want, 1, 2, and 3. Because if you just use 1 and 3 again, you're going to get like the same equation, or 3y minus z equals negative 7, right? Okay, so I have to use equation number 2. What do I need to get rid of, though? No? You guys are just guessing.
X.
Why should I get rid of x?
Because there's no X
In the equation you just found, right?
Yeah.
So do you guys understand that? So we need to get rid of x using equation 2 somehow. Because we already have an equation that has x that's missing. Because now we would have two equations that have y and z, and you'd be able to find y and z.
Oh.
Does that make
Use
sense?
the second and third.
Yeah, so you can use 2 with either one, it doesn't matter, but we have to use 2. So I'm going to use maybe 2 and, let's use 2 and 3. What am I going to have to multiply one of the equations by? You can't multiply by 0. That just gets rid of everything. So what, x? We want to get rid of x, remember? So I'm going to multiply by 2. You guys see it? That way I have x and negative 2x. So I have 2x plus 2y minus z equals 1. Stop the chatter. Now here's where people would make mistakes. People will always write like 1 there. They forget to multiply all the way through. So make sure you're not doing that on your homework. All right, add straight down. X's go away. On this one, the y's go away, which is very nice. Because now I just have an equation that just has z. So I get 3z equals 3, so I already know z is 1. Can I find any other variables now?
Why?
Y. Because you have negative 3y plus z equals 7, right? You just need z and one other, you need y. So an equation that just has 2 variables to find the other one. So I get negative 3y plus 1 equals 7. Negative 3y equals 6, so y is negative 2. And now plug into any equation that you want to find x. So x minus 2y minus z equals 6. So I'm using equation number 1 from the very beginning. So I have x minus 2 times negative 2 minus 1 equals 6. So x plus 4 minus 1 equals 6. So I get x equals 3. Write it in x, comma, y, comma, z. So 3, negative 2, 1. We haven't talked about what this is, but this is a point in 3 dimensions. So we're going to talk about 3 dimensions next time. I do want to do one more example when you guys come back from break, but I'll go ahead and let you guys go on break now. All right, so number 2, so same process. Let's try number 2. Now, what do you notice about number 2 that might be convenient for us?
Oh, first equation doesn't have
Right, first equation doesn't have a z. So that means we probably want to find a way to combine the second and third equations so that we get rid of z. All right, so we're going to combine these to get rid of z. Because this top one was missing z. All right, so when I look at those two equations, what am I going to have to multiply by in order to get rid of z? I'm going to multiply the second equation by -2, right? So I'm going to have -6x minus 8y minus 4z equals -12. Again, this is a place where most people will mess up, so make sure you're multiplying the number by -2 as well. The bottom equation is 7x plus 3y plus 4z equals 29. So when you add straight down, you get x minus 5y equals 17. Okay, that's an equation that has x and y. We already have another equation that has x and y, so we can solve for x and y. So my other equation was 5x plus 2y equals 4. I want to do the least multiplication that I possibly need, so we can multiply the top equation by -5, right? So now I get -5x plus 25y equals -85. And I have 5x plus 2y equals 4 still. So when I add straight down, the x's go away. I get 27y equals -81. So y is -3. Okay, so now plug in to any equation. So let's do the one where I have x minus 5y equals 17. So any equation that has y and only one other variable. Okay, so that's going to be x minus 5 times -3. What was the question?
You can even use equations that you made by combining them.
Yep, you don't have to use the original equations. You can use these equations that you've created when you combined. So that's x plus 15 equals 17. So x equals 2. And then plug into any equation that has z to find z. So I have 3x plus 4y plus 2z equals 6. So 3 times 2, so 6, plus 4 times y was -3, so -12, plus 2z equals 6. So I have -6 plus 2z equals 6. Be careful, a lot of people will get 0 here, but you add 6 to both sides. So I have 2z equals 12, so z is 6. Oops. So that means my final answer, right, with x, y, and z. So it's 2, -3, 6. So that's your point in 3 dimensions. Those are actual points on a graph. So we'll talk more about graphing those tomorrow. Easy, easy.